Yes, you are. You are. Okay, we're on page 253. This is going to be very quick. So, how do log graphs relate to exponentials? So they are the inverse of each other, correct? So if we have the graph of log base 3 of x, there it is here, rising to the left. What's the domain of this graph? What numbers can you not log? 0. So our domain would be x is greater than 0, right? And we have a horizontal asymptote at x is equal to 0. Okay. Now you don't have to write any of this down. You don't have to know the process. You just have to know the end result, okay? So if I take log 1/3 of x, and I say, okay, we're going to graph this. Well, I'm going to rewrite it first. Do you remember the change of base rule from yesterday? It said if I have a log of some base b, I can change that to any base I want by taking the log of the argument a of base. What is the base when you don't write the number? 10. So this would be log base 10 of a over the log of the base, or sorry, it shouldn't be a capital B, lowercase b. And now you don't want to erase, whatever. Lowercase b. Of log of the base of the original, okay? These are equal. So if I'm going to do it to this one, okay, I can change the base, and I'm going to change it to base 3. So that would turn into log base 3 of x, the argument, divided by log base 3 of the original base. Okay, that's just applying the formula. And then, because we're clever, if you look on the sideboard, the very far bit there with the identities, the top identity says log base b of b to the n. If the bases match, right? Then it's just the exponent. So is there any way I can write this 1/3 as base e, i.e. get rid of the fraction? -3, -1, 3 to the power of -1. So I could rewrite it as top stays the same. The bottom becomes 3 to the -1, right? So what happens to the bottom? What is its value now? -1, right? Because these two things match, so it just becomes the exponent, which is the identity we learned yesterday. And so now I get log base 3 of x divided by -1, which is the same as writing, I'll write it down here, -1 log base 3 of x. Okay. What does that negative mean? Over the x-axis. It's an a value of -1, right? So it flips the graph over the x-axis. So all these points here flip up here. This 1 will move to -1. This 2 will move to -2. And so the graph will look like that. That is log of 1/3 x. Did the vertical asymptote change? No. So our domain is still x is greater than 0. Okay. All I want you to remember from this page is that if you have a base in a log graph that is less than 1, in other words, it is, if the base is less than 1, but bigger than 0, because the base cannot be 0. It will be following log graph like this. It'll look like this, okay? If it's a whole number greater than 1 or any number greater than 1, log base 1.5, it will be rising like that, okay? So if I said, sketch these two graphs here, excuse me, log base 5 of x, and I just said, make a quick sketch of that graph. Is it rising or falling? Rising. Log graph looks like that, has an asymptote of x is equal to 0. That's it. If I said make a quick sketch of the graph log 1/5 x, you would make it fall. Asymptote at the same spot. X is equal to 0. That's it. Are we okay with that? Going once, going twice. We are going to skip to page. We good, Is? All right. We're gonna go skip that page. We're gonna skip that stuff. And we're gonna go right to here, page 256. Boom. Okay. We got the same graph, log base 3 of x. Now, if I put a 2 in front of it, what does that 2 do? Vertical stretch by 2. So it takes all my x values and they move 2, or get multiplied by 2. But that's really the only thing that changes. It just gets steeper. 2 log base 3 of x. That's it. What's the domain of that graph? Is the vertical asymptote in the same spot? Yes. So the domain is going to be greater than 0. And vertical asymptote, which I will shorthand VA, will be x is equal to 0. That's all it changed. We just stretched it vertically. We didn't move it horizontally. Number 2, log base 3 of x minus 2, all in brackets. What does that 2 represent? What letter? Transformation. It's an h value. So that means we went which way? Right 2. So if we move it right 2, so now our vertical asymptote was at 0. If you move it left or right, just like the k value moves the horizontal asymptote in a exponential graph, h value will move the vertical asymptote left or right in a logarithmic graph. So our vertical asymptote has moved to 2. And now the graph looks like that. So that is log base 3 of x minus 2. If we move the vertical asymptote 2 units to the right, what is now the domain? There you go. Because if I put 1 in there, 1 minus 2 is a negative number. You cannot log a negative number. Okay? Going once. Good? All right, last one. What does this 2 do? Moves it down. It's a k value because it's not in brackets with the x. So this graph will be down 2. Is that going to change the domain, the asymptote, any of that kind of stuff? Nope. So remember, we're moving the original, this black one here. So it moves it down 2. So now the graph looks like that. domain is x is greater than 0. Range is all real numbers because it's going all the way up and all the way down, right? Even though it's flattening out, it's still going up, just at a very, very slow rate. So that's why I don't worry about range. Are we okay with that? So all you need to know, what I would expect you to be able to do, there's some space here, is on a test, if I said, sketch this, all I expect is for you to get whether it's rising or falling and get the asymptote right. So where is my asymptote on this graph? What's my domain on this graph? Okay, so what did we do? What does this 2 do to it? Not 2. That moves it 2 units to the left, right? So it should be -2, right? The h value is your vertical asymptote on a log graph. So x is equal to -2. Vertical asymptote. Is it rising or falling? The graph. Falling because the base is 1/5. Just a very general sketch. That's all I'm expecting. Okay? It'll probably be a multiple choice question that I ask you to match it to. Okay? Is that okay? All right, we're not doing any questions from this lesson. We're moving on to the next lesson. So, let me pause this. Okay. Page 271, solving exponential equations. So we have already solved some exponential equations. We have solved ones like these. How would you solve this? You had one of them on your quiz. How would you solve a question like 1a? What would you do? You change them so they all have the same base, right? So we would change the 4 to 2 squared. And then once you have equal bases, you ignore the bases and equate the exponents. 2x is equal to x plus 3. So you move it over and you get x is equal to 3. Right? That's what you want to do. You want to try to do that because it is simple and fast and less complex than what we're about to learn right now. However, it only works if you can make them a common base. And unfortunately, in real world stuff and in most problems, you cannot make them a common base. So you have to use other techniques. All right? So we're going to have a look at this question. 2 to the power of x is equal to 50. So the first thing when you get a question like this, excuse me. How do you make 50 base 2? No, 2 to some, I mean, you can, but it's a weird number. It's a decimal. Okay? So we can't do that. So what we need to do is we need to use our log skills. These are the 3 things we looked at yesterday. The product rule, when you are adding logs together, it's the same as multiplying the arguments. When you are subtracting, it's the same as dividing the arguments. And the power rule, which says if you have an exponent on the argument, you can knock it down. And that's the rule we want to use. That's the main one that we're going to use today. So I need to get this x out of the exponent. There's only one way to do that. You can't just bring it down. You can only bring it down if you have a log in front of it. Okay? So we're going to put a log there. But what you do to one side, you have to do the other side. Now, You have choices. You can choose any log you want, any base. But there's two bases that you can punch into a calculator. What are they? 10 and E, except for Madison's calculator that you can punch any base into. But 10 and E are the common bases, all right? So we'll use 10, okay? So all you do is log in front of it. And what you do to one side, you have to do the other side. So I log the other side. This causes or allows me to bring down the X. Okay, so I can just drop the X like that. Now, the benefit of this is you can use algebra now, your basic regular algebra skills, okay? Because even though it doesn't look like anything you've ever seen, this is the same as this. It's the same as that. It's just, instead of having a 2, we have log 2. Instead of having a 10, I guess I can make that a 50. We have log 50. What I'm saying is log 50 is just a number. You can punch it in your calculator and get it. It's like a decimal. I don't know. Let's do log 2 is 0.3. So this equation is the same as x times 0.3. And I'm rounding here. Log 50 is 1.7. Again, rounding. These two are the same. How would you solve this one? What would you do? You divide by 0.3, right? It's gone. And then whatever that is your answer, okay? Same thing for this. You divide off the log 2, okay? So x is equal to log 50 divided by log 2. Now, that is what is called the exact solution, okay? Because it's written with logs. If you write them as an approximate solution to the nearest hundredth, you have to round off your decimal. It's not as accurate, but gives you more of a usable answer, I guess, if you're doing mechanical calculations or engineering and things like that. And the answer is 5.64. Okay. Is that okay for everybody? All right. I'm going to move to the next page. We've done the first one. Well, we just did one exactly like that. Let's do B. Let's have a look at B here. 8x plus 4 is equal to 40. How does that differ than the one on the previous page or this one here? Yeah, we're adding it to something. So what you want to do is you want to just get one term on the left, one term on the right. So I'm going to subtract off the 4. And I'll have 8 to the power of x is equal to 36. As I wrote 63. Okay. We need to get that variable out of the exponent position. How do you do that? You log it. Okay. That's what allows it to fall, allows you to bring it down. You can use base 10, you can use E, you can use whatever you want, but base 10 and E are ones you can punch in your calculator. Base E is also called the natural log, right? I'm going to use that just because I like to write ln. But you can write log. Your answer will be exactly the same. So it's natural log of 8 to the power of x is equal to the natural log of 36. And as soon as you do that, what happens to that x? It goes boom, falls down. So I drop the x down. And then to solve for x, I do what? Divide it off. I don't know what that is. That would be the exact value answer. If you're doing the approximate answer, you're going to get 1.723. Okay? All right, one more before I give you some questions. 6 to the power of 3x is equal to 3 to the power of 2x minus 1. Can't make them the same base, so what do? You log them. Now what? Why do we log them? To get the exponents down. So we drop the exponents. So the first one turns into 3x log 6 equals, you have to drop the entire exponent down. And when you do, you have to remember to bracket it because log 3 is being multiplied by both of those things. So now you have to FOIL it in or distribute it. And I get 3x log 6 is equal to 2x log 3 minus log 3. Sorry? Yeah, there's a 1 in front of it. You don't have. Now, who remembers our algebra? What do we do now? If you're solving for x, what do you need to do? All your x's together on one side and get everything else that doesn't have an x to the other side. I'm going to move this 2x log 3 over here. Okay? So 3x minus 2x log 3 equals negative log 3. Now what do I want to do? Make them the same base? Is that what you said? Well, they are the same base already, right? We're all in base 10. But you can't combine them because you have numbers in front. But what you can do is factor out an x. We're trying to solve for x. So we just want one single x. So if I pull that x out, I get this. All right, how do I solve for x? Yeah, divide off that whole big clump of brackets. So that would be the exact value answer on a test. That's fine. However, you can simplify it. I'm just going to show you how you do that because the book does it. The bottom here, you can move these exponents up. And you get negative log 3 over log 6 to the power 3 minus log 3 squared. 16, duh. So I'm going to get log 3 over log 216 minus log 9 Go this way. And then because those are being subtracted, you can divide them. So that's log 216 over log 9. Anybody know what 216 divided by 9 is? 24. I'm running out of room here. So the simple answer would be negative log 3 over log 24. You can just give me the first one. Any questions? No? All right, I would like you to do number 1C and number 3, please. Okay, I don't know what page this is. What page is this? 272. All right. Now we have 2 times 3 to the power of x minus 2 is equal to 7x. What do you want to do here? Can we make them the same base? That's the first thing you should ask yourself. No, you cannot. So we're going to have to log them. You have a choice. You can divide off this 2 if you want, but it's not going to simplify anything because this is 7 to the power of x. You won't get like 3.5 to the power of x. You can't do that. So my advice would be just leave it and log both sides as is. Okay. So we log it. What is that sound? Sounds like it's coming from above. Oh well, whatever. Okay, what's my next step here? What do we want to do? Why do we log? Okay, you want to drop the exponents. The problem is the 2 and the 3 have different exponents. So we need to separate them first. I know. So if you're multiplying, what does that mean you can do to the arguments? You can add the logs of the arguments. So we can rewrite it as log 2 plus log 3 to the x minus 2 is equal to, I can drop this exponent down, that. So this is one of the problems. When you log something, it takes a simple expression and it expands it out, but then we'll bring it back together. Now what do? I can drop the exponent x minus 2, right? So log 2 plus x minus 2 bracketed times 3 is equal to x log 7. And then you have to FOIL in the log 3 or distribute it. So I get log 2 Okay, now what do? Yes. You get all the x's, all terms with an x on one side. What would be the easiest move here? Usually we go to collect everything on the left, but we might as well move this x here, the middle one, x log 3, to the right-hand side, and then all the x's are there and everything else is on the other side. It doesn't matter, but if it's only one step versus multiple steps, you might as well do that. And then what? Factor the x out. Once you've logged and expanded it, it's the same process every single time. And then divide that off. And you can just leave it like that. Okay. If you collect things on the other side than what I did here, your answer would have the top numbers switched. It would be 2 log 3 minus log 2, and the bottom switched as well. It's still the same answer. Okay. One more question from this lesson, and then we can say sayonara to this one. So we're gonna, are we okay? Has everybody got that? And scroll to here. 7e to the negative 2x plus 9 is equal to 12. We need to solve for x. So what jumps out at you right away with this question? The e. As soon as you see e, you should start thinking about natural logs. Okay, because remember, natural logs, ln, is actually log base e, right? Okay, so now what do I do? What's my first step here? Subtract the 9, okay? All right, we got that. Now what? Okay, what do you mean convert to logs? Natural log both sides, is that what you're saying? Okay, now you could do that and it's not wrong, okay? However, because this 7 is a number and this 3 is a number, whereas in the previous one, it was like, I'll just look at it. It was a 2 and a 7 to the power of x. So I didn't want to divide those off. But because these are numbers, you can, and it makes a little bit of sense here. All right, so divide off the 7. I'll show you how to do it your way after. You get the same answer. And now you want a natural log. You want to use the natural log when you have e. You don't have to. You can do base 10 if you really want to. But if you do the natural log, what happens to the left side? If natural log is base e, what this is really saying is log base e of e to the negative 2x. Everything will disappear except the exponent, right? So the left side just becomes negative 2x is equal to natural log of 3 over 7. So what's my final step? Divide by negative 2. I think that is 0.424. I think, I don't know. But anyway, your answer is natural log of 3 divided by 7, all divided by negative 2. Okay, so when you see e, start thinking of the natural log. Any questions about that? 4 and 7, please.